You probably remember learning about plate tectonics in school, right? This idea that massive plates of rock are just kind of floating around, moving the continents. But what if the engine that drives that whole process, the very force that builds mountains and creates oceans, has been totally misunderstood? Today, we're diving into a source that claims one of geology's biggest theories has a huge, gaping hole right in the middle of it.
See, plate tectonics is taught like it's a done deal, like it's settled science. But according to the material we're looking at, there's one massive unanswered question. What is actually moving the continents? What's the engine? And the argument is, without a real, confirmed engine, the whole theory might be on some seriously shaky ground.
To really get what's going on, we have to rewind the clock and talk about the guy who started this whole conversation, Alfred Wegener. His story isn't just about rocks and maps, it's a classic tale of an outsider going up against a very rigid scientific establishment.
So get this. Wegener throws his idea of continental drift out there way back in 1912, and for the next 50 years, it was basically rejected. He was ridiculed by his peers for most of his life. And the truly tragic part? He died on an expedition long before he was ever proven right. He never got to see his vindication.
So why all the hate? Why were they so resistant? Our source says it boils down to one word: professionalism. You see, Wegener wasn't a professional geologist. He was a meteorologist and astronomer. So the establishment didn't dismiss him because his evidence was bad. They dismissed him because he wasn't in their club. And our author makes the point that this kind of attitude is a huge brake on scientific progress.
And here is the ultimate irony. The #1 criticism they threw at Wegener was, you can't explain what's moving the continents. It was their big gotcha. But here's the kicker. The modern theory that eventually replaced his has the exact same problem. They still don't have a confirmed driving force.
Okay, so let's dig into the official candidates for that driving force. Our source takes a look at the 3 main ideas that geology textbooks propose and argues that every single one of them is either based on circular logic or just doesn't hold up.
First up is mantle dynamics. This is the big one, the idea you probably heard in science class. The thinking is that the Earth's mantle is this hot, gooey layer, and there are these slow-moving convection currents inside it. These currents supposedly drag the crustal plates along for the ride, kind of like a massive planetary conveyor belt. But that brings up a pretty obvious question, right? If the convection currents in the mantle are moving the plates, then what's causing the convection currents to move in the first place? What's the ultimate source of the motion? And that's where our source calls it out as circular reasoning. It's like saying the car is moving because the wheels are turning. Yeah, we know the wheels are turning, but what's turning the wheels? You haven't actually identified the engine. You're just using one effect to explain another without ever getting to the primary cause.
Next, let's look at rotational forces. Remember how Wegener was mocked for proposing this pole flight idea? Well, this is where the hypocrisy really shines according to our source. Because if you look at modern lists of potential driving forces, guess what's on there? Pole flight, the Coriolis effect, the very same ideas. And the best part is, scientists today still admit these forces are way too weak to actually move a continent. So it was a laughable idea then, but it's a valid hypothesis now?
And finally, we've got gravity. You hear terms like ridge push and slab pull, but once again, we're stuck in that same logical loop. Okay, so a high ridge at the bottom of the ocean pushes a plate away. Fine, but what made the ridge high to begin with? A heavy plate gets pulled down into a trench. Great, but what created the trench for it to be pulled into again? Again and again, we're just describing the mechanics, not the motor. So, if the mainstream theories are all missing something, what's the alternative? This is where our source material stops poking holes and starts building something new. It proposes a single powerful force that it claims has been completely overlooked. The answer in 2 words is charge, as in electricity. The theory is that a constant flow of electrical charge is moving through our planet, and this is the engine that creates all the heat, all the energy, and all the motion that we call geology. And this theory isn't just about Earth, it's cosmic. It proposes a whole causal chain. A universal field of charge feeds galaxies. The galactic core feeds our sun. The sun fills the solar system with its ambient charge. Earth then pulls in that charge at its poles, and it's the flow of this energy through the planet that drives everything from volcanoes to continental drift. Now that is a huge claim. So where's the evidence? Well, what's fascinating is that the author argues we don't need some new discovery. They say the proof is already there, hiding in plain sight in existing data from organizations like NOAA.
According to the source, if you look at NOAA maps of Earth's energy emissions, you see the theory's predictions perfectly laid out.
The theory says charge enters at the poles and exits at the equator. And what do the maps show? Low energy at the poles, the intake valves, and a huge band of high energy emission around the equator, the exhaust port. It even accounts for weird imbalances, like a big charge hole at the South Pole.
So, how can flowing charge physically push a continent? Well, think of the Earth's crust as being lumpy. It has thicker, denser parts and thinner, less dense parts. The theory goes that this charge flows like water, taking the path of least resistance. When it hits a big, dense landmass, it gets blocked and has to flow around it. That diversion creates an immense sideways force. The charge is pushed one way, and the continent gets shoved the other.
Now for the real test. Can this theory explain one of the biggest puzzles in geology, the supercontinent cycle? Why did a giant landmass like Pangaea break apart? And why do the continents seem like they're on a collision course to reform?
Here's how the theory explains the breakup. A giant continent like Pangaea acts as a huge insulator, blocking the flow of charge. So that energy has to go somewhere. It gets diverted and channeled into the weakest spots, the seams between the plates. All that focused energy, which we see as volcanism and earthquakes, builds and builds until it literally rips the supercontinent to pieces.
Okay, so that's why they break apart. But why do they come back together? Well, according to this theory, it's just basic physics. First, the spin of the Earth is constantly nudging all land masses toward the equator. And second, you've got all these different-sized continents moving at different speeds all on the surface of a sphere. Collisions are just inevitable. It's like a slow-motion demolition derby where a pileup is guaranteed, eventually forming a new supercontinent. And the whole cycle begins again.
So in the end, the author argues that charge is the unifying theory that geology has been looking for. It's not circular like the other models. It provides the engine, it explains the forces, and it predicts the direction. It's presented as the one solution that solves all the problems at once.
And that leaves us with a pretty provocative final thought. This whole journey has been about one source's challenge to geology. But it makes you wonder, right? If it's possible that we've overlooked a fundamental force in a field this established, what else in science might we think we understand when we're really just seeing the effect and have completely missed the true cause?